All right. Hey, everybody. I'm going to be doing a presentation on Terraform drift detection and reporting. Yeah, let's get started. I'm an infrastructure engineer. I've been in DevOps for about like 8 years now, mostly focused on cloud systems. And the past few years, infrastructure as code has been super enthralling for me. Terraform is definitely something near and dear to my heart. Okay, so a little bit about me. I've been using Terraform since about version 07, back when like Terraform Remote was still associated with the CLI. Yeah, but before then I used OpenStack Heat and AWS CloudFormation, which are more vendor-specific infrastructure as code tools. And then I just recognized the power of how many different cloud resources you could control within those platforms through these tools, but there wasn't something that could kind of go across multi-cloud or different providers. Like if you wanted to associate like DNS or get storage from an external provider, there wasn't like a single tool that I could use to combine all these things together, but Terraform definitely fills in that gap. And I've also been involved in the Terraform community a few different ways. So I've been working at a few different startups the past few years and managed about like 700 plus states at this point. And that's kind of where my talk stems from, is drift detection and reporting, because when you're managing states at scale, it's really, really difficult to find what resources are being modified, changed, or need to be destroyed, or what is actually live in your infrastructure, and then what is defined in HCL. And there's a lot of like back and forth that can go on, and a lot of manual investigation that might need to be done in order to do that. So also Atlantis, I feel like, I don't know if Atlantis has really been mentioned recently, but it's a really good GitHub collaboration tool for distributed teams to work on the same Terraform state and Terraform project simultaneously. And it's all done through like GitHub PRs or GitLab PRs, whatever source control you use. It's very, very powerful. So that community is great. And then discuss HashiCorp. A lot of great community interaction happens there. And I've kind of helped post some things for resolving issues, mostly when I was learning Terraform 12. And then most recently, I was part of the Hackathon Hackstravaganza provided by HashiCorp. And I did some of this custom tool using terraform-exec, which I'll go into later. Okay, yep, so Terraform. I think Terraform's been explained. A lot of people are probably familiar with what it is, but it's a stateful way to control resources that are present in the cloud based off whatever provider you're choosing. So if you're using like AWS or OpenStack or Google Cloud Platform, maybe you're using like DNS from like Fastly or Cloudflare. And it's a way to associate these resources together and in a single unified way. So it's a very, very strong tool. But I'll go into more about like state and how to detect Terraform drift shortly. So yeah, the first section here is what is Terraform state? So we can go into that. Okay, so defining Terraform state. Pretty much the gist of what Terraform state is stored in a specific file called terraform.tf state. This is generated by the Terraform CLI tool, and it contains a lot of things that Terraform needs in order to function correctly. So it's pretty much the source of truth, and Terraform references this constantly when you're doing plans and when you're applying new changes to your infrastructure. So some of the things that it contains is state metadata. So here I've mentioned like unique state file counter. So there's like a versioning system within the state file that's stored what backend is being used. So where it's being stored in the cloud, or if it's local, then that's not there. And also the Terraform version that's being used. When you apply something on Terraform, the version of the Terraform binary you're using becomes the minimum version that you have to use in order to make future changes to that state. And yeah, there's some other resources there. So like resource dependencies to see how resources are interconnected. So if there's attributes being referenced by another Terraform resource, that kind of mapping is identified. And let's see. So how do you store Terraform state? As I mentioned earlier, there's that file terraform.tf state. And this is just wherever you're doing it, your Terraform init and then Terraform plan, the file will just be created in that directory if you're not using a backend. But if you're using a backend, there's plenty of ways to kind of store this in a cloud resource or cloud provider. So Terraform Cloud is what I actually primarily use. And then they have a great way of interfacing with that through the web UI. cloud storage, so Google Cloud Storage, AWS, S3, OpenStack, Swift. You can also store it in container orchestration platforms. So Consul, the service discovery thing, has like a key value store that you can store it. And then Kubernetes, you can also encode the state file and then store it as a Kubernetes secret. Okay, so now going on to more about the main concept behind finding Terraform drift, which is like how we can understand this. So what is Terraform state drift? So this occurs when pretty much that state file that is stored in the cloud or locally has resources that are not defined, or I should say it has an absence of resources that are not defined in that state, but they may be present in a cloud provider. So for example, let's say I created a EC2 instance on the console in AWS, and I wanted to reference that in my Terraform project. By default, Terraform has no way of understanding where that is because it's not defined as HCL. So I would have to either import that instance in order for Terraform to recognize that specific resource. But if it's not present, you can kind of do a few different things. So I've mentioned a few different ways that drift can be detected. So like I mentioned, live changes to existing resources. So that AWS instance, if I like change the name tag, for example, and then I do a Terraform plan, Terraform will do a refresh and update. So it will kind of pull the most recent live changes, and then it will show kind of a drift type of like a resource change. And there are also some false positives. So based off like certain providers maybe that are in beta or are switching APIs behind the scenes, you could have like default values that are constantly being overwritten, and it kind of shows like a false change. So like that attribute will be set, and then it'll be set to null, and then it'll be set again each time you do a plan. And I'll show that a little bit later because that actually is present in my infrastructure at the moment. All right, let's move on here. So how does Terraform handle detecting state drift? So natively through the Terraform CLI, there's a command called Terraform refresh, and this is run behind the scenes every time you call a Terraform plan. And this will pretty much just pull your existing state from wherever the backend is, and then it will plan or create kind of like a local copy of a Terraform plan, and it'll increment the version. As mentioned earlier, there's like a unique version counter. So Terraform has kind of like a way of doing a diff based off what is stored in your backend and what is defined in your HCL. So it'll kind of like compare those two things. And that's how you get the general like add, change, destroy counter from Terraform here. So yeah, so this command checks the previously written state file and pulls updated information for any resources or data sources defined in HCL. Okay, so how to identify Terraform state drift at scale? This is much more trickier, I think, depending on how your repositories are set up. Generally, I've used mono repos in the past, so we'll have like one big Git repo that has a bunch of different smaller directories, and each directory will essentially be a Terraform service or a Terraform project. So that will contain its own HCL and have its own backend, have its own state per directory. So once you have like hundreds of these directories, I don't necessarily want to go in as an operator, go to each individual directory, do a Terraform plan, manually review everything, and then see if it's good or not, because that's just very time consuming. So how I've seen it resolved in the past is mostly just like some software is written to kind of do a diff check for like a plan, and then essentially a plan, and then do it in parallel across all of these directories. So I've kind of mentioned here, like there's the Terraform plan-out function, this command that's highlighted. You can kind of pretty much save that plan and then download your Terraform state and then do a manual diff. And there is logic that you can write to kind of see what resources are present within the state that is applied and live, and then what is defined in your HCL. So there are other ways to like output as well. So you could send, like if you write your own custom software, you could like integrate it with Slack or Discord or send an email, or just like have a report to your standard out within a terminal. So I think third-party software is becoming more and more apparent in the field. Like a few years ago, didn't really exist. There were some that were very, very bespoke for certain use cases, mostly like AWS type software for drift detection, but I'll get into that a little bit more shortly. Cool. So now that we have Terraform state, we kind of understand what it is, and we know how state is stored and how it can be stored in a backend. How do you fix it, right? So if you identify state across one of these projects and you see like changes or modifications, what do you do? So if pretty much you can just follow the core Terraform workflow, which is to write your HCL and then plan it via the Terraform CLI and then apply it. Generally, that will fix most drift because you will ensure that Terraform, once again, is the source of truth for your infrastructure or what's defined in your cloud infrastructure. And if it's not, so well, I guess I should mention if there are drift cases that aren't supported by doing the Terraform core workflow, like for example, somebody does create a manual resource in the cloud and has not imported it, you can just simply use Terraform import or use like a tool like Terraformer by Google, and you can kind of identify these all resources defined in a cloud provider like Google or AWS, and that will kind of do a bunch of importing for you. Also, you can ensure that the HCL contains changes that you want to find in resources. So this will kind of overwrite or modify an existing resource in the cloud. So if you have that EC2 instance that you've imported, and then now you want to change the tags or associate a new IP address with the instance, you can just define that in HCL and do a Terraform apply. So at scale, it's kind of tough because you don't necessarily want to go through all of your repos and do Terraform apply and then wait however long for those changes to take effect. But we can see how we can solve it at scale shortly with software. So drift detection software. We can go over, I just look at GitHub. So I know of a few that I've used in the past. I've mostly used in-house, like kind of bespoke software, but there are also some new forerunners that I've found recently, and then some software that I've written myself that I will be explaining shortly. Okay, so why do I think drift detection software is important? So as I mentioned earlier, once you have like hundreds of states that you are managing simultaneously, you don't necessarily want to go through each one by one. If you're trying to keep your state as up to date as possible, right? Because that can be very, very tedious and difficult to manage. You can reduce operator and practitioner time because if you do it programmatically or do it in parallel, it just saves a bunch of time instead of doing it one by one. Now also just having like reports provided for you by software, so you can just look at a glance. As an operator, you'll have the insight of like, okay, these are our critical Terraform services, so let me fix those first. And then these other ones, although they do have changes or do have drift, they're not as high priority. And you can kind of like gauge and make the most effective choice based off the information you have. And then drift is always, well, for my use case, drift is inevitable. It's always going to occur in Terraform as you keep using it through Terraform version changes, through API provider changes behind the scenes, or just through like people are manually changing attributes associated with cloud resources. And that is going to, when you do a refresh or pull from a data source or pull the most recent resource, you'll find that that drift in the Terraform plan section. So there is a way to remedy the last one for provider APIs. You can version pin. So I do that for some of my, like for example, the Kubernetes provider provided by HashiCorp is super great. They've recently switched to a new version, but I have some tooling that I use like to convert HCL or to convert YAML into HCL, and that only supports like version 113. So I have it pinned to kind of suit my use case, but for everybody, it might not be the correct solution. Because staying native, there's upsides to being like as standard as possible. So there's two types of software that I want to go over. I just have two options for both. There's legacy software that has kind of like, these were the prototypes, these were like the proof of concepts that drift detection can be solved at scale. And they're open source tools that I found on GitHub. And there's one in specific, drifter, that I will kind of talk a little bit more into because I have more insight, because I've read that code base and I didn't necessarily use it because I don't use AWS too much recently, but I'll go into that. So that's the legacy software is mostly software that has all of the logic defined manually or like custom. So that means like pulling GitHub projects or source control projects so that they can be planned individually, as well as doing like parsing of Terraform plan files. So that means, or even just like counting resources that are associated in the Terraform state file. So it's like, since each resource is defined, or like a module can have a collection of resources defined, it would go through each resource and like essentially do a match for anything with resource, grab that, and then see if it is present in the Terraform state. So it was a little more archaic way of doing that because it wasn't like a really scalable way from what I had noticed. But yeah, all the software is like pre-2019 or 2019-ish. So it's not super maintained, but I'll still shout them out because even for myself, like writing modern software, it's been a very good help to just reference these old pieces of software. And so I will go into this next thing called modern software. I only call it modern because there's a really good Golang library that was created by the HashiCorp SDK team, and it's called terraform-exec. So essentially, you can invoke all of the functionality of Terraform CLI, but programmatically. So I've mentioned a few different things that are supported. So refresh, init, plan, show, and apply, and destroy. You can do all of these things through the code base, which is great. And then also, I will shout out like the Terraform Cloud Development Kit. You can do something similar. I don't have as much experience with it, but that is also an alternative if you wanted to manage Terraform resources programmatically. Cool. So I'm going to go over two legacy tools here. The first one, Digirati Labs Drifter. This was actually the first thing I had discovered when I was struggling with drift detection tools, maybe like 2017, 2018. I saw this tool. It was AWS specific, but it was written in Python. And this kind of served as a basis of an in-house tool that I had written at a prior startup I worked for. And I had pretty much like studied this code base and made it more flexible for the like Google Cloud and Kubernetes, since it didn't really support those two things. But it had like custom planning, or it had a GitHub downloader essentially function. So you could download repos programmatically. And then you also could do plan parsing, but it was much more like using regex and doing matching of strings versus a more consistent way, I guess, through like a interface or structure like terraform-exec provides. The other one, Virtual DOM TFDD, I believe this was created by Lob, an employee of Lob. And this is a very similar tool to Drifter. It worked in the same kind of way of like having custom logic to download repositories. But I believe this one also scanned AWS resources, and then it would see what's actually live on AWS and ensure that those things that were not present in Terraform were reported. So you could actually see if I had like an EBS cloud storage like created and it wasn't defined in Terraform, it would actually give you a notice of, or at least the intent was to give you like a notice of these things exist in the cloud but are not present in your HCL. So either import them or define them in your HCL. So I think that is actually a very cool core cool feature that's pretty core to drift detection, because most things are just like, oh, just import through Terraform import, but you don't know what you should import. So I'm going to go into the modern software. Drift control. I think yesterday there was a talk about that reference drift control. I actually hadn't heard of this until like last week when I was kind of doing some research for other tools. But this is actually, I'm really excited to see drift control expand to other cloud platforms. Right now it's AWS specific, but they have a really good tool that's CLI based, and it uses Terraform exec under the hood, but it allows you to pretty much scan, similar to what that previous tool I was talking about did. It would scan your AWS account. It would show you what resources are present, and it would tell you, okay, you can use Terraform import or Terraformer or some kind of tool to import these things into your infrastructure. And then otherwise, if all your AWS resources are existing in the HCL, it would kind of just do a concise like report saying, okay, these are the added, changed, destroyed resources in your cloud based off your HCL and based off what's in AWS. So here they have like, I'll just go ahead and read some of their description here. Scans the cloud provider, maps resources with infrastructure as code, analyze diff and warn about drift and unwanted unmanaged resources. And then you can push it out to multiple different formats, which is cool. And also ignore resources is quite good. And then lastly here, I have a tool that I've been writing, and this was kind of inspired by Drifter, as I mentioned, the first legacy tool that I went over. And this is also using Terraform exec, but this is more, it's not cloud provider specific. It's just Terraform provider specific, essentially. But I use this for like Cloudflare, Kubernetes, GitHub, and some other providers. And so far, it's been pretty good for me, although it's very basic and it like works on my system. I'm still trying to get it packaged so it can work more agnostically and in the cloud. I'd like to ideally run this as a cron job. But I'll go into how Clairvoyance works in the next section here. So I have a list of like some of the current things that it does: provides drift report for a target directory, detects if any changes are present, reports to standard out, and then the stats that are reported are added, changed, deleted, total projects, and versions, as well as some Clairvoyance metadata. And the name is Clairvoyance. I kind of just liked the whole term of like future sight. So you can kind of see what your infrastructure is, where it is currently, and then what you need to do to kind of change or get it up to the most recent version, just to like fix all those stress. I do have a screenshot later on that I will show. So inspiration for why I developed this tool. As I mentioned, most of the software that I found was AWS specific. So I couldn't really use it without kind of modifying how the backend functionality works and then kind of changing all the AWS functionality to another cloud provider's equivalents. So there was some like work that needed to be done in any case. If I wanted to use those tools, I couldn't use them out of the box. So since I use GKE a lot and I want to detect drift with Kubernetes resources, it just made sense to kind of write something more bespoke. I use Discord a lot versus Slack, although, I mean, there's no reason you couldn't support both, but I just wanted to report to Discord. So, and I also wanted just to be better at Golang development. So I thought Terraform exec was a great use of, or a great excuse for me to start writing more Go. All right, so how this works. Pretty much Clairvoyance, it's a command line tool, and you have to set it up with a few different environment variables. So namely just a project directory. And so if you have a project directory defined, it'll do a recursive search in that directory, find anything with the star.tf uniquely. It will record that parent directory and then store it in a list. And then it will kind of build a list of identified Terraform projects. Then it will do an initialize, Terraform init, Terraform plan, and a Terraform show in sequence to kind of gain drift insight. And then it will do a diff between the state file that is live in whatever backend, as well as that -out file that I mentioned a little bit earlier. So those two things are kind of diffed against each other. So live resources and locally planned resources, and it will parse the string for like modified resources. So like the add, change, destroy. and then it will associate that with whatever directory it was run against. And then lastly, I just output it all in a table. So I have like a drift detection table and I have like a no changes table. Running the tool. So right now it is runnable. You might need some work to get it working on your system, but I do have a make file. So you could just do like make std out, and then that should work because it does build a Go binary locally. You will need to configure some environment variables like I mentioned. So if you want the Terraform version to be explicitly used, you can define that. And then the project dir. And then, yeah, the Clairvoyance CLI tool can be run from the terminal. And I would like to expand it to be serverless or like a Kubernetes cron job. And you just simply do Clairvoyance report and then wherever you want to report. So right now it's just standard out, but Discord is the next thing up. And this is what it looks like actually. So this, if you look down here where I do a grep for the Clairvoyance project directory in red, you can see on my MacBook, that's where, that's like kind of like the parent project. So this is like I do a bunch of like game server stuff. So this, I just wanted to quickly figure out like what game servers I need to update. And as you can see, I need to actually update quite a bit. And I do have some bugs like where version doesn't show up, but I'm planning on fixing that stuff. So this first table up here is just a quick glance of like what resources are added, changed, deleted. So I probably would want to check out these ones with 7 adds because likely there's something definitely going wrong as far as the drift goes. And then the changes, I would want to see what is actually diffed in these games here. So, and also just lastly, just to prevent bloat, I've made a second table to show no changes. And also it does support multiple versions. So eventually I would like to use like the required version associated with the Terraform provider block or the Terraform block for each project, but I still have ways to go for that. And it does everything in parallel. So instead of like doing your Terraform init, plan, apply one by one, it does everything in parallel. So 40 seconds, pretty good for like 10 plus services here. And then I just have some future plans of like things that I would like to implement. As I mentioned, the required version thing, I think that's really cool. You can just grep that or parse that from the Terraform, like the main.tf file, right? And then you can explicitly use that version, planning multiple states across multiple backends, and then Atlantis or local file or Terraform Cloud workspaces, finding a way to like parse these files or like off to Terraform Cloud and then kind of programmatically pull all your workspaces or something like that. Generate HCL code suggestions, which I think is super interesting, but quite difficult to pull off, and then reporting to other mediums. And then I have, since we're running a bit low on time, I have like plans to containerize this in Docker. I have like a make directive Docker test that I can run to do a brief test, but that still needs a bit of work. But yeah, lastly, I just wanted to say you can find more of me at my blog, rulin.com. It's listed there. And then there you can see all my links, and you can also see my GitHub, and it's Clairvoyance is available on my GitHub if you'd like to check it out, see the code, see how Terraform exec works.